For most of human history, reality has felt open. We look outward and see distance without edges. We look inward and imagine knowledge without limits. Each generation inherits the quiet assumption that whatever cannot be reached today will be reached tomorrow, that every wall is temporary, that every mystery is simply waiting for better tools. Progress reinforces this belief. We crossed oceans that once felt endless. We left the surface of our planet. We sent instruments beyond the edges of the solar system. Each success whispers the same message: keep going, and there will always be more. But what if that intuition is wrong? What if reality itself is not open in the way we imagine? What if existence has borders that do not yield to effort, intelligence, or time? This is an uncomfortable thought because it challenges something deeply human. We are not just curious creatures. We are boundary breakers. We define ourselves by what we overcome. Limits feel temporary by nature, like puzzles meant to be solved. And yet, the universe has been quietly suggesting a different story. Not loudly, not dramatically, just through small, persistent refusals. Certain speeds cannot be exceeded. Certain regions cannot be reached. Certain questions return no answers, no matter how carefully they are asked. These are not failures of technology. They are not gaps waiting to be filled. They behave more like fundamental features of reality, as if the universe is saying gently but firmly, this far and no further. At first, limits appear practical. We lack energy. We lack time. We lack precision. These feel solvable, temporary, the kind of obstacles history has always overcome. But some limits remain even when those excuses are removed. Even in theory, even in perfect conditions, even in equations unconstrained by engineering, certain boundaries remain intact. They do not bend, they do not weaken. They simply exist, and that changes the question entirely. If some limits cannot be crossed even in principle, then they are not obstacles. They are structure. They define the shape of what is possible. They tell us not just what we cannot do, but what reality itself is willing to allow. This raises a subtle tension. We tend to think of the universe as infinite, smooth, and continuous, a vast expanse where more is always waiting beyond the horizon. But limits suggest something else entirely. They suggest edges, not physical walls, but conceptual boundaries, places where familiar ideas stop working, where language fails, where mathematics grows quiet, and those edges appear again and again, in space, in time, in matter, in knowledge itself. The deeper we look, the more often we encounter horizons rather than doorways. This does not mean exploration is pointless. It does not mean curiosity is misplaced. But it may mean that exploration has a shape, that knowledge has a ceiling, that reality is not an open field, but a carefully constrained landscape. And if that is true, then the most important question is no longer how far we can go. It becomes something quieter and far more unsettling. What kind of universe places limits on itself? To answer that, we need to step back and look at the first moments when science itself began to notice that not everything yields to persistence. Moments when progress did not reveal new freedom, but instead uncovered the first unmovable boundaries. Because long before we questioned the limits of reality, reality had already been setting them. The idea that reality might have limits did not arrive all at once. It emerged slowly, almost reluctantly, through moments when nature refused to cooperate. In the early days of science, the universe felt generous. Problems yielded to calculation. patterns revealed themselves. Each discovery seemed to promise that given enough time and effort, everything would eventually be understood. There was confidence in momentum. A belief that knowledge expanded outward without resistance. Then, quietly, that confidence began to fracture. One of the first signs came from light. For a long time, light was assumed to be instantaneous. It simply was. A perfect messenger that carried information without delay. This assumption felt natural, almost comforting. If light had no speed limit, then distance was merely an inconvenience. But experiments told a different story. Light, it turned out, had a speed. A specific one. A number that did not change, no matter how fast the observer moved, no matter how the experiment was arranged. At first, this seemed like a technical detail. Interesting, but manageable. It was not. As understanding deepened, that speed revealed itself not as a property of light alone, but as a boundary for reality itself. Nothing carrying information could move faster. Not matter, not energy, not cause and effect. Nature had drawn a line. This was not a limit imposed by technology or materials. It was woven into the structure of space and time. Even in thought experiments, even in perfectly imagined universes, the barrier remained intact. And that was unsettling. Around the same time, astronomy delivered a different kind of refusal. For centuries, stars were seen as eternal, fixed points of light, unchanged across human history. They felt permanent, reliable, beyond decay. The heavens, it was believed, were stable in a way Earth was not. Then physics entered the picture. As scientists began to understand how stars produce energy, a quiet realization followed. Stars burn fuel. Fuel runs out. Every star has a lifespan, even the largest ones. Some live for billions of years. Others die quickly, violently, leaving behind remnants that barely resemble their former selves. But none last forever. There is no exception, no eternal fire. The sky, once imagined as timeless, suddenly felt temporary. And this too was not negotiable. No amount of intervention could grant a star infinite life. The equations were clear, the processes unavoidable. Nature was not interested in permanence. Another limit emerged from energy itself. As machines improved and ambitions grew, it seemed reasonable to imagine unlimited power given enough resources, bigger engines, better efficiency, endless growth. But thermodynamics intervened. Energy, science revealed, follows strict rules. Some transformations are irreversible, some losses are unavoidable. Perfect efficiency is forbidden. Entropy always increases. This was not a practical inconvenience. It was a fundamental statement about how the universe behaves. You can slow entropy. You can localize order. But you cannot stop the overall trend. Again, nature said no. These early limits shared a common trait. They were not dramatic failures. There was no moment of collapse, no public declaration that science had reached a dead end. Instead, the boundaries revealed themselves gently through consistency, through results that repeated no matter how carefully experiments were designed. At first, scientists treated these limits as isolated facts. The speed of light belonged to optics. Stellar lifespans belonged to astronomy. Entropy belonged to thermodynamics. But over time, a pattern became difficult to ignore. Reality was not infinitely permissive. It allowed complexity, growth, and structure, but only within defined constraints. There were ceilings, horizons, conditions that could not be violated. This realization marked a subtle shift in scientific thinking. Progress no longer meant assuming that every problem had a solution waiting just beyond current understanding. It meant recognizing that some questions might be asking for things the universe simply does not offer, not because it is incomplete, but because it is structured. And once this idea settled in, scientists began to look for limits more deliberately, not as obstacles to be overcome, but as clues, as signals pointing toward the deeper architecture of reality itself. Because if the universe imposes limits consistently, then those limits are telling us something. They are not the end of inquiry. They are the beginning of a different kind of understanding. One that starts not with freedom, but with boundaries that cannot be crossed, no matter how far knowledge advances. At first, the speed of light looks like an ordinary number, a value written in textbooks, a constant memorized, referenced, calculated around. It feels technical, almost mundane, just another parameter in the machinery of physics. But the deeper scientists looked, the more that number began to behave less like a measurement and more like a wall. Light does not merely move quickly, it moves as fast as reality allows. Nothing that carries information can outrun it. Not matter, not energy, not influence itself. This is not a limitation of engines or materials. It is not something future technology will eventually bypass. Even in theory, even in imagination constrained only by mathematics, the barrier holds. Cause cannot outrun effect. This is where the speed of light stops being about light at all. It becomes about time. If information could travel faster than light, effects could arrive before their causes. Events could influence the past. Paradoxes would not be rare curiosities. They would be unavoidable. The universe would lose its ability to remain internally consistent. Reality, it seems, refuses this instability. So the speed of light stands guard, quietly enforcing order. It ensures that time has direction, that sequences remain sequences, that the universe does not fold in on itself under the weight of contradiction. What makes this boundary especially unsettling is how universal it is. You cannot cheat it by moving closer. You cannot bypass it by accelerating harder. You cannot evade it by changing reference frames. No matter how fast you go, light always moves away from you at the same speed. This is deeply counterintuitive. In everyday life, speeds add together. Run toward a moving object and it approaches faster. But light ignores this logic entirely. It behaves as if the universe itself is adjusting around it, bending space and time to preserve the limit. And that is exactly what happens. As objects approach the speed of light, time slows for them. Distances contract, energy requirements climb toward infinity. The closer you get to the boundary, the more reality resists. Not violently, firmly. The universe does not punish attempts to cross the limit. It simply makes crossing impossible. This resistance is not arbitrary. It is woven into the structure of space-time itself. Space and time are not passive arenas where events unfold freely. They are active participants, reshaping themselves to protect this boundary, which leads to a profound realization. The speed of light is not the speed of light, it is the speed of causality. It defines how fast the universe can respond to itself, how quickly information can propagate, how large a region can be connected by cause and effect. Beyond that speed, the concept of now breaks down. There is no shared present, no common sequence of events, only disconnected regions, unable to influence one another. In this sense, the universe is not a single unified stage. It is partitioned. Every observer carries a bubble of influence around them, defined by this limit. Events outside that bubble may exist, but they cannot matter yet, and some may never matter at all. This turns distance into something more than space. It becomes time-bound separation. Even if the universe lasts forever, even if technology advances without limit, there will always be places that remain causally unreachable. Not because they are too far away in space, but because the clock will never allow contact. This is not a temporary horizon. It is permanent. And that permanence changes how we think about exploration. It suggests that no matter how ambitious our reach becomes, the universe will always remain larger than our influence. There will always be regions that exist independently of us, untouched and untouchable. The speed of light does not merely slow us down. It defines the shape of reality itself. And once this boundary is accepted, another unsettling idea follows naturally. Because if causality has limits, then so does knowledge. And the next boundary waiting to be explored is not about speed, but about how far we can ever see. When people imagine an edge to the universe, they often picture a place, a distant boundary, a final wall of stars, a point where space simply stops. This image feels intuitive, almost comforting, because it treats the universe like a territory that can, in principle, be crossed. But the real edge of the universe is nothing like that. It is not a location you could travel to. It is not a barrier you could collide with. It is not even truly about distance. It is about time. The observable universe has an edge, but that edge exists because the universe has an age. Light needs time to travel, and time, no matter how patient we are, only allows so much information to reach us. Every direction we look, we are looking backward. The light from distant galaxies has spent billions of years crossing expanding space just to arrive here. Some of it began its journey when the universe was young, dense, and almost unrecognizable. And beyond a certain point, there has simply not been enough time for light to reach us at all. Those regions are not hidden. They are not blocked. They are simply too early, too far back in time for their signals to arrive. This creates a horizon unlike any other, a boundary that does not separate space from non-space, but knowledge from permanent ignorance. A line beyond which reality continues to exist, but can never be observed. And it is not static. As time passes, the observable universe grows. More light arrives, more regions come into view. But expansion complicates this picture in a way that feels almost cruel. Space itself is stretching. Some regions beyond the horizon are moving away from us so quickly that their light will never reach us, no matter how long we wait. The expansion of space outpaces the ability of light to cross it. These places are not just unseen, they are causally disconnected forever. They exist, they evolve. They may host galaxies, stars, perhaps even complex structures, but they are unreachable in principle. No signal sent today will ever arrive there. No message from there will ever reach us. The separation is absolute. This is where the idea of distance breaks down. These regions are not far away in the usual sense. They are separated by the rules of space-time itself. The universe has effectively partitioned reality into islands of causal connection, each surrounded by horizons that cannot be crossed, and we are confined to one of them. This realization carries a strange emotional weight. We tend to think of the universe as something we might eventually map in full, given enough time and technology. But the observable universe is not a temporary limitation. It is a permanent one. There are parts of reality that will never enter our past light cone. They will never be part of our story. Even a civilization that lasts for trillions of years will face the same horizon. This is not because the universe is hiding anything. It is because time itself enforces boundaries. The edge of the observable universe is not dramatic. There is no visible line in space, no sudden drop-off, just a gradual fading of information until the cosmos becomes unknowable, not due to lack of effort, but due to the structure of reality. And that changes how we understand existence. Reality is larger than what can ever be observed. The universe we talk about, measure, and model is only a fraction of what actually exists. Beyond our horizon lies a vast continuation that will forever remain theoretical, inferred only through mathematics and implication. This is not a failure of science. It is a statement about limits. The universe allows us to see far, astonishingly far, but not all the way. It grants access to a window, not the whole landscape. And that window is defined not by curiosity or intelligence, but by time itself, which leads to a deeper, more unsettling thought. If some regions of reality are permanently beyond observation, then there may be truths that exist without ever being known, facts that are real but inaccessible, structures that influence nothing we can ever touch. The universe, it seems, does not guarantee full transparency. It allows understanding only up to a point, and beyond that point, reality continues on its own terms, unconcerned with whether it is ever seen. At small scales, distance feels simple. Something is close or far. If it is far, it can be reached with enough time, energy, or persistence. Distance feels like a challenge, not a barrier, a matter of effort. But the universe does not share this intuition. On cosmic scales, distance stops behaving the way our minds expect. It becomes something deeper, more final, something that does not care about speed, ambition, or patience. Because in the universe, far away does not always mean reachable. As space expands, it stretches not just the gaps between galaxies, but the meaning of separation itself. Two objects can be moving away from each other not because they are traveling through space, but because space between them is growing. And that growth has consequences that feel deeply unintuitive. Some galaxies are not receding slowly. They are being carried away by the expansion of space so rapidly that even light cannot bridge the gap. No matter how long we wait, no signal we send today will ever arrive. These places are not distant in the ordinary sense. They are cut off. This is where distance becomes meaningless, because meaning depends on possibility. A place is only far if it can, in principle, be reached. When reachability disappears, distance stops being a useful concept. You could imagine an engine of unlimited power, a spacecraft that never slows, never fails, never runs out of time. Even then, some regions of the universe would remain inaccessible. Not because of weakness, but because space-time itself refuses connection. The universe has regions that exist beyond pursuit. This realization quietly reshapes exploration. It tells us that the universe is not a continuous field of opportunity. It is divided, segmented, structured by horizons that do not announce themselves, but enforce absolute separation. Two galaxies can be visible to each other today, exchanging light, shaping each other's history. And yet, due to expansion, there may come a time when they drift beyond causal contact forever. The universe does not preserve relationships. It allows them only temporarily. In this way, distance becomes time-dependent. A place that is reachable now may not be reachable later. A connection that exists today may silently dissolve without warning. There is no dramatic moment when separation occurs, just a gradual slipping beyond influence. This gives the universe a strange emotional texture. It is not static. It does not freeze relationships in place. It slowly erases them. On the largest scales, the universe behaves less like a map and more like a process that creates isolation naturally, without intention or malice. Regions drift into solitude simply because the rules allow it. And once that happens, nothing can reverse it. No technology, no discovery, no future breakthrough. Some separations are permanent the moment they form. This is not because the universe is hostile. It is because it is governed by geometry, expansion, and time. The rules do not adapt to our expectations. They do not soften for curiosity. They simply operate, which leads to an unsettling implication. If distance can become meaningless, then access itself is conditional. What we can know depends not only on intelligence or observation, but on where and when we exist in cosmic history. Reality does not offer the same universe to every observer. It offers each one a fragment. And that brings us closer to the next boundary, because even within the fragment we inhabit, there are limits not imposed by distance or time, but by the very act of trying to measure reality at all. At first, measurement feels like the safest path to truth. You observe carefully. You record precisely. You repeat the experiment until doubt fades. Measurement, we believe, reveals reality as it is. But the universe quietly disagrees, because there are things that cannot be measured without being altered. Not because our tools are crude, not because our methods are flawed, but because observation itself is an interaction. And interaction leaves a trace. On small scales, this becomes unavoidable. To measure something, you must touch it in some way. You must exchange energy. You must disturb it, even slightly. And sometimes that disturbance is not a side effect. It is the limit. In the quantum world, this boundary reveals itself with unsettling clarity. You can know where a particle is or how fast it is moving, but you cannot know both with perfect precision at the same time. The more tightly you measure one, the more the other slips away. This is not a failure of instruments. It is a rule. Reality does not allow complete disclosure. And the reason is simple, yet deeply uncomfortable. Measurement changes the system being measured. There is no neutral perspective, no invisible observer standing outside the universe, recording facts without influence. Every observation becomes participation. Even worse, the act of choosing what to measure defines what can be known. When you set up an experiment, you are not simply uncovering reality. You are asking it a very specific question. And reality answers only that question at the cost of obscuring others. This means knowledge is not additive in the way we expect. You cannot simply pile facts on top of each other until the full picture appears. Each measurement sharpens one feature while blurring another. Clarity always comes with loss. And this is not limited to quantum particles. On larger scales, measurement still encounters boundaries. The more complex a system becomes, the harder it is to observe without interference. Climate, ecosystems, even entire galaxies respond to observation through indirect effects. The tools we use shape the data we receive. The universe is not a static object waiting to be catalogued. It is dynamic, reactive, sensitive to interaction. This introduces a profound constraint on knowledge. Some aspects of reality are mutually exclusive. You can understand one deeply only by letting another remain vague. Precision in one domain demands uncertainty in another. This trade-off is not temporary. It is built into the structure of existence. In this way, observation becomes a boundary, not a wall that stops inquiry, but a narrowing corridor. The deeper you go, the more choices you must make about what kind of truth you are willing to see and what you are willing to lose. There is no measurement without consequence, and this challenges a comforting assumption. We like to believe that with enough data, enough time, and enough intelligence, reality will eventually reveal itself completely. But limits of measurement suggest otherwise. They suggest that reality is not fully accessible from within itself, that some information is protected not by secrecy, but by structure, that the universe preserves ambiguity as a fundamental feature, not a flaw. Knowledge, then, is not about removing all uncertainty. It is about navigating it. And once we accept that observation itself imposes limits, a deeper question emerges. Because if measurement fails at small scales, then there may be regions where reality itself stops behaving in measurable ways at all. Places where space and time lose their familiar meaning. Places where the concept of measurement simply collapses. And that boundary waits at the smallest scales imaginable. At everyday scales, reality feels smooth. Surfaces look continuous. Motion flows without interruption. Space appears infinitely divisible, cut a distance in half, then half again, and again without end. This intuition feels natural. It feels obvious. But the universe does not agree. When scientists pushed deeper into the foundations of matter and energy, they encountered something unexpected. Reality stopped behaving like a smooth fabric and began to resemble something granular, structured, quantized. There were boundaries. Energy did not vary freely. It came in packets. Light was not just a wave, but also a particle. Matter could not occupy arbitrary states, only allowed ones. Nature, it seemed, preferred steps over flows. This was deeply unsettling because it suggested that infinity, at least the kind we casually imagine, might not exist in physical reality. The universe does not allow unlimited resolution. There is a smallest change that matters, a smallest difference that can exist. Below that, the concept of more detail loses meaning. Uncertainty sits at the center of this realization. Not uncertainty as ignorance, but uncertainty as structure. Some properties of reality simply cannot be simultaneously defined. Position and momentum, energy and time. The universe enforces trade-offs that cannot be negotiated away. This is not randomness layered on top of order. It is order that includes uncertainty by design. Quantum boundaries do not merely limit what we know. They limit what can be. Reality itself refuses to be pinned down beyond a certain precision. Attempt to force it, and it responds not with clarity, but with indeterminacy. This suggests something profound. Reality is not infinitely smooth beneath the surface. It does not resolve endlessly into finer detail. At some scale, the universe says, "This is as sharp as it gets." Below that point, familiar concepts dissolve. Distance becomes ambiguous. Time loses continuity. Causality grows fragile. We are accustomed to thinking of boundaries as failures of theory, places where understanding has not yet arrived. But quantum boundaries behave differently. They persist even when the theory is complete, even when predictions are exact. They are not gaps. They are features. This reframes the nature of physical law. Instead of describing a reality that exists independently of limits, physics begins to look like a language describing what reality allows and what it forbids. Smooth infinity, once taken for granted, starts to look like a mathematical convenience rather than a physical truth. Useful for calculation, powerful for abstraction, but not something the universe actually instantiates. And that changes how we imagine the foundations of existence. If there is a smallest unit of action, a smallest meaningful interval, then reality is not infinitely divisible. It has resolution, texture, a kind of grain that cannot be sanded away. Beyond that grain, questions lose meaning, not because answers are hidden, but because the universe no longer supports the distinctions the questions rely on. This is a boundary unlike distance or speed. It is not about how far or how fast. It is about how deep we can go before reality itself stops offering structure. And that leads us forward, because if quantum boundaries define the smallest scales of existence, then there must be a point where space and time themselves break down completely. A place where the universe no longer provides even the language to describe what is happening. That place lies at a scale so extreme that physics itself begins to fall silent. There is a scale at which the universe stops answering questions, not because it is hiding something, not because our instruments are too weak, but because the questions themselves stop making sense. This scale is known as the Planck scale, and it is not just small. It is the smallest meaningful scale reality appears to allow. At this level, space can no longer be treated as a smooth stage. Time can no longer be treated as a flowing dimension. The concepts we rely on, distance, duration, position, sequence, begin to fracture. They do not bend, they break. The Planck scale marks a boundary where our two most successful descriptions of reality collide. Quantum mechanics governs the very small. General relativity governs space, time, and gravity. Each works with extraordinary precision in its domain. But here, they refuse to coexist. When gravity becomes strong at quantum scales, the equations stop agreeing. Space is predicted to fluctuate violently. Time loses its direction. Cause and effect blur into something unstable and undefined. It is not that reality becomes chaotic, it becomes undefined. Below the Planck length, asking where something is has no clear meaning. Asking when something happens loses coherence. The universe no longer supports the framework required for measurement, prediction, or description. This is not a technical inconvenience, it is a hard stop. Physics does not gradually become more difficult as this scale is approached. It simply ceases to function in the way we understand it. The mathematical language goes quiet. The symbols no longer point to anything stable. And this silence is important. It suggests that reality itself may have a minimum resolution. That space and time are not infinitely divisible, but built from something more fundamental, something we do not yet know how to describe. Many theories attempt to speak beyond this boundary. They imagine loops, strings, networks, discrete units of geometry. But none have been confirmed. None have crossed the threshold from speculation into testable reality. For now, the Planck scale remains a horizon, not a place we cannot reach yet, but a place where reaching stops being a meaningful concept at all. This forces a difficult admission. There may be aspects of reality that exist without space and time as we understand them. Structures that do not unfold in space-time but give rise to space-time. Foundations that are not smaller pieces of the universe but something entirely different. And we may never be able to observe them directly, not because they are hidden, but because observation itself requires space and time to already exist. To look beneath them may be logically impossible. This is one of the strongest hints that reality has intrinsic limits, not imposed by technology, not imposed by intelligence, but imposed by coherence itself. The universe allows description only down to a point. Beyond that, it does not reveal more detail. It withdraws the rules that make detail meaningful. And once we accept that there is a scale where space and time dissolve, a deeper question begins to form. Because if even the fabric of reality has boundaries, then there must be regions where those boundaries do not just limit access, they permanently seal it. Places where reality closes in on itself and refuses to share what lies beyond. Those places exist, and we know them by another name. Black holes are often described as places you cannot escape. That description is true, but it is incomplete. Because what makes a black hole truly unsettling is not what happens to matter that falls in. It is what happens to information. At the boundary of a black hole lies a horizon, not a physical surface, not a wall you could touch, but a line in space-time beyond which return is impossible. Once crossed, all future paths point inward, not metaphorically, geometrically. This is not a dramatic event. Nothing special happens at the horizon itself. No explosion, no sudden force. To a falling observer, the crossing can feel almost ordinary. And that is what makes it disturbing. Because from the outside, something very different occurs. Information stops coming back. Light emitted just before the crossing grows weaker, slower, redder, until it fades into nothing. Signals stretch endlessly. Time appears to freeze. From the perspective of the universe outside, the falling object never quite crosses. It simply becomes inaccessible. This is not just about escape. It is about knowledge. Once information passes the horizon, it can no longer influence the outside universe. No message can return. No detail can be recovered through direct observation. The black hole does not destroy information in an obvious way. It removes it from causal contact. Reality becomes partitioned. Inside the horizon, events still occur. Processes unfold. Structures may exist, but they do so in a region that is permanently sealed off, not by distance, not by time, by the rules of spacetime itself. This transforms black holes into something more than cosmic traps. They become informational boundaries. For a long time, physicists believed that black holes erased information entirely, that whatever fell in was gone forever, reduced to a few simple properties: mass, charge, and spin. Everything else, history, structure, complexity, vanished. If true, this would violate one of the deepest principles of physics, that information is conserved. The universe, once again, refuse to offer an easy answer. Modern theories suggest that information is not destroyed, but hidden, encoded on the horizon itself. Smeared across its surface in ways we cannot yet fully decode. Preserved, but inaccessible. This is a subtle distinction. Information exists, but it cannot be retrieved. And this may be the most unsettling limit of all, because it implies that reality can contain truths that are permanently sealed away, facts that are real, structured, and meaningful, yet unreachable in principle, not temporarily lost, not waiting for better instruments, simply inaccessible. Black holes show us that the universe is willing to hide parts of itself completely, not out of malice, not out of secrecy, but because its structure allows regions where causality ends. Inside a black hole, the future does not branch outward, it collapses inward. Time becomes directional in a way that cannot be reversed. And beyond a certain point, even the idea of what happens next loses coherence. These are not just extreme objects. They are demonstrations. They prove that reality contains domains where limits are absolute, where questions cannot be answered not because they are difficult, but because they are no longer allowed. And once we accept that black holes hide information behind unbreakable horizons, a deeper realization follows. If the universe permits regions of permanent inaccessibility, then limits are not rare exceptions. They are part of the design, which leads to a quieter, more troubling question, because black holes are not the only places where information becomes unreachable. There may be boundaries that apply not to matter or space, but to understanding itself. Limits that do not form around objects but around minds. Time feels familiar. We wake up, we remember, we move forward. Cause precedes effect. Past becomes present. Present slips into memory. This sequence feels so natural that it is easy to mistake it for an absolute feature of reality. But the universe treats time very differently than we do. In physics, the fundamental laws do not strongly prefer a direction. Most equations work just as well forward as they do backward. On the deepest levels, there is nothing that clearly insists that time must flow only one way. And yet, we do. We never experience tomorrow before yesterday. We never remember the future. We never move backward through moments already lived. This asymmetry is one of the most quietly profound limits in all of existence. Time, it seems, allows only one direction of travel. At first, this appears to be a practical consequence. Entropy increases. Systems move from order to disorder. Eggs break but never unbreak. Heat spreads but does not gather itself again. The arrow of time feels tied to decay. But that explanation is incomplete. Entropy explains why processes look irreversible. It does not explain why we are trapped inside that irreversibility. It does not explain why consciousness itself experiences time as a one-way journey rather than a static landscape. We are embedded in time in a way that offers no exit. We cannot pause it. We cannot reverse it. We cannot step outside it to view it whole. Even when physics allows time dilation, slowing clocks, stretching durations, it never allows reversal. The arrow remains intact. No matter how distorted, it always points forward. This suggests that time is not just a coordinate, it is a boundary. We often speak about the past and the future as places. We imagine before and after as regions of reality laid out along a line. But this language may be misleading. It may be projecting human intuition onto something that does not share our perspective. Perhaps the universe does not experience time at all. Perhaps before and after are not features of reality, but features of observers moving through it. The flow we feel may be tied not to time itself, but to how information accumulates in memory, how entropy structures experience, how minds function. If that is true, then time is not simply something we are in, it is something we cannot leave. This makes time one of the most absolute limits imaginable. You cannot reach the past, even though it exists in some sense. You cannot access the future, even though it is allowed with the laws of physics. You are confined to a moving slice, a thin, ever-shifting present. And that confinement is total. No technology bypasses it. No intelligence transcends it. No discovery weakens it. Every civilization that ever exists will face the same restriction. No matter how advanced, no matter how far it spreads through space, it will still move forward one moment at a time. This reframes the idea of limits entirely. Some boundaries restrict where we can go. Some restrict what we can see. Time restricts what we can ever experience. And it does so quietly, without resistance, without warning. It simply carries us along, indifferent to desire or understanding, which raises a subtle and unsettling thought. If time itself is a limit, if forward motion is the only option, then understanding may also be directional. Knowledge may be constrained not just by what exists, but by when we exist. There may be truths that can only be known from certain moments, never revisited, never fully grasped from within the flow. And that brings us closer to the most personal boundary of all. Because beyond limits of space, measurement, and time, there may be limits tied not to the universe, but to the minds trying to understand it. Reality feels three-dimensional, up and down, left and right, forward and back. This framework is so deeply embedded in perception that it feels complete, exhaustive, as if space itself has revealed all of its structure to us simply by being experienced. But physics has been quietly suggesting otherwise. Again and again, the equations allow for more dimensions than we can perceive, not as science fiction, not as metaphor, but as mathematically consistent extensions of reality itself. These dimensions are not hidden behind walls. They are not folded away in distant regions of space. They are not places one could travel to. They are simply inaccessible. To understand this, it helps to imagine a simpler world, a two-dimensional surface inhabited by beings who can move only forward, backward, left, and right. For them, up does not exist, not as a mystery, not as a secret, as a non-concept. Even if a third dimension surrounded them, intersected them, shaped their world, they would have no sensory access to it. Any influence from above would appear indirect, unexplained, almost magical, not hidden, just unreachable. This is how higher dimensions may relate to us. Modern theories suggest that reality could have additional spatial dimensions woven into its structure. Dimensions that influence forces, shape particles, and determine fundamental constants, yet remain beyond direct experience. We do not see them. We do not move through them. We do not feel them. But that does not mean they are absent. They may be tightly constrained, compact, or structured in ways that prevent interaction at human scales. Not blocked by barriers, but limited by geometry itself. The universe may simply not permit us to enter those dimensions, just as it does not permit us to leave time or exceed the speed of light. This introduces a quiet but profound shift in perspective. Reality may be richer than what experience allows. The world we perceive could be a projection, a cross-section, a slice through a deeper structure that we are never meant to fully inhabit. And that raises an unsettling question. How much of reality do we mistake for completeness simply because it is all we can access? If higher dimensions exist, they would not announce themselves. They would not glow or shimmer. Their presence would be subtle, encoded into the behavior of particles, the strengths of forces, the stability of matter itself. We would not see them, we would infer them. And inference is fragile. It depends on interpretation. On theory, on assumptions about what is possible, a structure that cannot be directly experienced is always at risk of being dismissed, simplified away, or misunderstood. This makes dimensional limits especially strange. They do not feel like walls. They feel like absences we are not equipped to notice. Reality may have layers we permanently lack the senses to perceive, not because they are concealed, but because perception itself has boundaries. Our minds evolved to navigate a specific slice of existence, not to comprehend its full architecture. In that sense, inaccessible dimensions are not a flaw in understanding. They are a reminder that experience is not the same as existence, that reality does not need to be accessible to be real, that the universe does not tailor itself to the limits of perception. And once this idea settles in, it becomes difficult to ignore its implication. If there are dimensions we cannot access, then there may be structures we cannot even imagine, relationships that exist without appearing, influences that shape outcomes without revealing their source. Reality may be larger than knowledge, not because it is distant, but because it is orthogonal to experience. And that leads us naturally to another boundary, because even within the dimensions we can access, not everything can influence everything else. The universe does not allow unlimited connection. It enforces separation at a deeper level than distance alone. The universe feels connected, a single cosmos unfolding as one continuous story. Events happen, consequences follow, and everything appears to belong to the same shared reality. This sense of unity feels natural, almost inevitable. But beneath that surface, the universe is deeply divided. Causality, the chain that links cause to effect, does not extend everywhere. It has reach. It has boundaries. And beyond those boundaries, influence simply stops. Two events can exist within the same universe and yet be forever unable to affect one another. Not temporarily, not due to distance alone, but because space-time itself refuses to connect them. These are not rare exceptions. They are built into the structure of reality. Every event occupies a region defined not just by where it happens, but by what it can influence and what can influence it in return. These regions are shaped by the speed of light, by expansion, by time itself. Together, they carve the universe into distinct domains of causality, causal islands. Within each island, events interact, signals propagate, histories unfold. But between islands, there is silence, not because nothing exists, but because nothing can cross the boundary. No message sent today will ever arrive. No action taken will ever matter there. No future technology will bridge the gap. Waiting does not help. Time does not soften this limit. In fact, time often reinforces it. As the universe expands, more regions slip beyond causal contact. Islands drift apart, sealed not by walls, but by geometry. This challenges a deeply held intuition. We tend to believe that if two things exist, there must be some possible interaction between them. That connection is only a matter of patience. That everything eventually touches everything else. Causality disagrees. Some separations are final from the moment they form. This has profound consequences for how we think about reality. It means that the universe is not a single, fully connected system. It is a patchwork of histories that never intersect. Vast regions where events unfold without ever entering our causal past or future. They are real, but they are irrelevant to us in the most literal sense of the word. Not emotionally irrelevant, causally irrelevant. Their existence does not influence our present, our future, or our understanding. They do not contribute signals, structure, or information. They simply exist alongside us, disconnected. This reframes the meaning of knowledge. To know something is not just to understand that it exists. It is to be able to be influenced by it, to receive information, to stand within the same causal network. Outside that network, reality becomes unreachable by definition. And this is not a limitation of observation. It is a limitation of influence itself. Even a perfectly informed observer with infinite patience and flawless instruments cannot learn about events outside their causal domain. Those events do not enter the story. They do not leave traces that can be followed back. The universe allows existence without interaction. This makes causality one of the most fundamental limits of all. More restrictive than distance, more absolute than speed. It determines not just what can be reached, but what can ever matter. Reality, it seems, is not fully shared. It is divided into countless isolated narratives, unfolding independently, never aware of one another's details. And once we accept that causality partitions the universe so completely, a deeply personal question begins to emerge. If reality itself is divided into causal islands, then where does that leave understanding? Are there limits not just to what exists, but to what any mind, no matter how advanced, can ever hope to comprehend? That question waits quietly ahead, at the boundary between the universe and the intelligence trying to understand it. Intelligence feels limitless from the inside. Thought expands. Questions multiply. Each answer seems to open 10 more doors. With enough time, enough data, enough processing power, it feels reasonable to assume that understanding will keep growing without bound. But the universe has been quietly suggesting otherwise. Because intelligence does not exist in a vacuum, it is embedded in reality. And reality imposes constraints that intelligence cannot step outside of, no matter how advanced it becomes. Every mind, biological or artificial, must operate within the same physical laws it tries to understand. It must observe from somewhere. It must process information through limited channels. It must rely on representations rather than direct access to reality itself. This creates a ceiling, not a sudden wall, but a gradual flattening, a point where additional intelligence yields diminishing returns, where more complexity no longer reveals deeper truth, but only reorganizes what is already known. There are questions that cannot be answered faster by thinking harder. There are problems that do not yield to brute force. Some truths require information that cannot be accessed. Others require perspectives that cannot be occupied. No amount of intelligence allows a system to step outside the universe it is part of. This is a deeply uncomfortable idea. We like to imagine that advanced civilizations, given enough time, will eventually understand everything. That intelligence naturally tends toward completeness, that ignorance is always temporary. But limits suggest a different picture. Understanding may have horizons, just like space does, regions of explanation that can be approached, modeled, approximated, but never fully entered. Not because the answers are hidden, but because they require conditions that no mind can satisfy. A system cannot fully understand itself from within. A model cannot contain all the details of what it represents. A mind cannot exceed the informational capacity of the universe it occupies. These are not technical problems. They are structural ones. Even perfect intelligence would still face incomplete information, inaccessible regions, irreversible processes, and fundamental uncertainty. It could predict with extraordinary accuracy, but not with total certainty. It could explain much, but not everything. This suggests that intelligence is not an infinite ladder. It is a bounded landscape. Different minds may reach different plateaus. Some will see farther than others. Some will connect patterns that remain invisible to the rest. But none will escape the underlying limits imposed by causality, measurement, and structure. And this applies equally to artificial intelligence. No matter how advanced, it would still be constrained by the same laws. It could simulate, infer, and extrapolate, but it could not access information that does not exist within its causal domain. It could not resolve uncertainty that reality itself preserves. This reframes intelligence in a humbling way. It is not a tool for total comprehension. It is a strategy for navigating partial truth. Understanding becomes an act of approximation rather than completion, a way of working effectively within limits rather than dissolving them. And perhaps this is not a failure. Perhaps intelligence is not meant to conquer reality, but to coexist with it, to build meaning and coherence inside a universe that does not offer full transparency. If that is true, then the ceiling of intelligence is not a tragedy. It is a condition, one that ensures mystery remains, not as an obstacle, but as a permanent feature of existence. Which brings us to a final, quieter thought. Because if intelligence has limits, then those limits may not be flaws to overcome. They may be necessary. Necessary for structure, necessary for stability, necessary for a universe that can exist at all. And that idea waits patiently at the end of this journey, where limits stop feeling restrictive and begin to feel essential. Limits often feel like failures. They frustrate curiosity. They interrupt progress. They suggest that something has gone wrong, that reality is incomplete, unfinished, or withholding answers we deserve to have. But what if that instinct is backward? What if limits are not defects in reality, but the very reason reality works at all? Consider a universe without boundaries, no maximum speed, no constraints on energy, no uncertainty, no separation. Every event influencing every other instantly without delay or resistance. Every possibility realized simultaneously without restriction. Such a universe would not be rich, it would be unstable. Without limits, there is no structure. Without structure, there is no persistence. Without persistence, nothing can last long enough to become meaningful. Patterns dissolve before they form. Differences collapse into uniformity. Cause and effect lose distinction. Limits create shape. The speed of light preserves order by protecting causality. Quantum uncertainty prevents reality from collapsing into rigid determinism. Horizons partition the universe into regions where histories can unfold independently. Entropy gives time direction, allowing memory, experience, and evolution. Each limit does something essential. They do not restrict reality arbitrarily, they enable it. A boundary is what allows a system to exist without tearing itself apart. It defines what can interact, what can change, and what must remain stable. Without boundaries, everything touches everything else at once, and nothing survives that kind of connection. Even information needs limits. If all information were accessible everywhere, always, then knowledge would lose meaning. There would be no discovery, no surprise, no learning. Understanding requires separation between known and unknown, between signal and noise. Limits preserve contrast. They allow complexity to arise slowly, locally, incrementally. They protect fragile structures from being overwhelmed by the totality of reality all at once. Life itself depends on this insulation. So does thought. So does identity. In this sense, limits are not walls. They are filters. They determine which interactions are allowed, which are forbidden, and which must remain potential rather than actual. They sculpt the universe into something that can evolve rather than collapse. This reframes frustration into appreciation. The fact that we cannot see everything, know everything, or reach everything may not be a mistake. It may be the reason there is anything to see, know, or reach in the first place. A universe with no limits would be perfectly transparent and perfectly empty of experience. Boundaries give rise to perspective. Perspective gives rise to meaning. And perhaps the most unsettling idea of all is this: if limits are necessary, then overcoming them entirely might destroy the very conditions that make understanding possible. There may be truths that can only exist because other truths remain inaccessible. Reality may depend on its own partial opacity. This does not diminish curiosity. It deepens it. It suggests that exploration is not about erasing all boundaries, but about learning how to live intelligently within them, how to build coherence in a universe that does not offer total clarity. Limits stop feeling like barriers. They begin to feel like supports. And once that shift happens, the final question changes. Instead of asking what lies beyond the limits we cannot cross, we begin to ask something quieter and far more personal. What does it mean to exist within a universe that is bounded, and to know that those bounds are permanent? That question does not demand an answer. It leads us gently toward a conclusion. In the end, the idea of limits changes how everything feels. At first, boundaries seem disappointing. They suggest that something is missing, that reality is smaller than our curiosity, that there are answers we will never reach, doors that will never open. But slowly, a different perspective emerges. If reality has limits we cannot cross, then meaning does not wait beyond them. It exists inside them. A universe without limits would offer no resistance, no contrast, no tension. Everything would be available at once. Every possibility realized immediately. Nothing would need patience. nothing would require choice, and nothing would matter. Meaning arises where access is incomplete, where not everything can be known at once. Where time forces sequence, distance creates separation, and uncertainty preserves possibility. Limits are what give experiences shape. They allow moments to exist instead of dissolving into totality. The universe does not need to be infinite to be profound. It only needs to be structured. Within its boundaries, stars are born and die. Matter organizes itself into complexity. Life emerges. Consciousness reflects. Questions form. Stories unfold. All of this happens not despite limits, but because of them. We move forward in time because time has direction. We discover because not everything is revealed. We care because not everything is accessible. If reality allowed total access, there would be nothing to explore. If every truth were exposed, there would be no wonder. Mystery is not a flaw in the universe. It is one of its essential features. And perhaps that is the quiet resolution. The universe is not withholding something we deserve. It is offering a space where meaning can exist at all. Limits protect that space. They preserve difference. They allow small regions of order to persist inside vast uncertainty. They make experience possible without overwhelming it. To exist inside a bounded reality is not a punishment. It is a condition, one that gives rise to curiosity, humility, and depth. One that ensures that understanding is always a journey rather than a destination. One that allows reality to remain larger than any single perspective without becoming inaccessible to all. So when we ask whether reality has limits we cannot cross, the answer may matter less than what follows from it. If some boundaries are permanent, then our task is not to escape them. It is to live thoughtfully within them, to explore what can be known, to respect what cannot, to find meaning not in infinite reach, but in finite presence. The universe does not need to reveal everything to be meaningful. Sometimes depth exists precisely because there is an edge, and perhaps that edge is not where understanding ends. It is where understanding becomes human.